combat the boredom. And I think working on your voice is one of those ways. But yeah, thank you. Thank you for pointing that out. It makes me, at least I can do one thing right.
All right. Well, with that, why don't we get underway? Welcome, everybody, to the April 4th, 2024 meeting of the Technical Advisory Council of the Confidential Computing Consortium. If you're joining us, then you probably have like-minded views that by working together in open source, we can probably do more to help make the world a little bit safer, make things a little bit harder for the bad guys out there by helping to protect data in use using confidential computing. We, as a open source organization with a lot of different companies here, also abide by the antitrust policy of the Linux Foundation. And you can see that on linuxfoundation.org/antitrust-policy. For today, we will recap what we did in the previous meeting and then get into some new topics. Mike Bursell might have an announcement or two, but I don't know if Mike's going to end up being able to join us today. Then Pawan is going to talk about a new SIG that is created in Outreach and ask for some engagement there. We have the NARC's annual review, and then a demo from VerTE. So a lot of good project work in the agenda for today. And then we'll check in on the project pipeline and some updates to the budget. And time permitting, we've got the terminology document or glossary to get back into. Anything else people were expecting to see? No? All right, well, with that, we've got, in the past, we would take a formal roll call, but we've moved away from that this year. But if we need to get into a vote for anything, we can always come back and do that. In addition to the voting members that you see here for the premier companies, we have a fully open organization here. Everybody is welcome to contribute in the conversations and to any of the deliverables that we're putting together. And so something that we do every meeting is if you haven't had a chance to introduce yourself to the rest of the crew here, feel free to pop off a mute. Let us know how you like to be addressed, where you're coming from, either what company or what part of the world, and what it is about confidential computing that interests you.
Morning. So my name.
So I think it's probably not just me, but I'm getting a lot of feedback off of Rachel's line.
Yeah, same.
Okay, so Rachel, we really want you to introduce yourself. So feel free to come back off of mute after the whatever technical difficulties abate.
Real quick, hi, I'm Bob Ryder. I'm from Booz Allen Hamilton, and I'm here. Richard Zach has been discussing confidential computing within a firm a fair amount, and we're interested in that for a number of applications. So here, in particularly for Richard's talk, but also here in general, a little bit more about confidential computing.
Awesome, great to have you, Bob. I think I did some work with Booz Allen Hamilton a long time ago out in the Reston-Herndon area. Where are we finding you?
I'm in Central Maryland, Annapolis Junction.
Fantastic. Thanks for joining us, Bob. Feel free to ask questions or jump in along the way.
And follow up, I'm Greg Starkey. I'm with Richard and Bob as well with Booz Allen Hamilton here in Central Maryland.
Excellent. Glad to have you.
I guess I could introduce myself. Hi, everybody. I'm Kevin. Pronouns are he, him. I'm working with Meta, and I'm coming from New York here. My main interest in confidential computing is like the attestation aspect of confidential computing.
Great. Thanks for joining from Meta. And I think Kevin is replacing Eric from from Meta. So nice to have you on as the official representative.
Can you hear me? So this is Nicholas
Yeah.
Meeting. I'm joining here from in Germany. I'm working at the IBM Research and Development Lab, my main interest about confidential computing is that from a technical and product management side, I worked on confidential computing since 5+ years, introducing secure execution in the Linux One and IBM Z space. And I'm the principal product manager for these offerings at IBM, Linux One and IBM Z. And if Rachel can talk, she's also product manager at IBM on the IBM cloud side with the mode focused on the x86 offerings there, while I'm taking care of, as said, the ones.
I'm still getting the same non-communication.
Yeah.
But I was audible. This is Nicholas.
Yeah, Nicholas. Yeah, thanks for joining, and joining from Germany, if I heard right.
Yes, you heard right. I'm joining from Germany.
Great. Well, it's wonderful to have both of you here from IBM, and sorry to Rachel that we're having some audio problems there and we don't get to hear from you directly. But of course, we've had Red Hat on as one of the initial members for the full longevity of the CCC, and we haven't had as much interaction with IBM. So it's great to have you both here with us today. All right, anybody else who hasn't had a chance to introduce themselves at least twice to the community so we all get to know each other a little more? All right, well, if you later want to introduce yourself, or you don't want to introduce yourself, but you still want to contribute, you're welcome to do that as we move along here. So last session, Alec was able to fill in and share, so thanks again for that, Alec. We had the Oakland update, and so if you missed any of that, we keep all of the recordings for the meeting posted to YouTube, and you can find the minutes and so forth in the governance repo. And I think as well as a link to all the rest of those materials, where there's also links on the confidential computing website. There were two other requests that were mentioned in the course of that meeting. One is from the GRC SIG. So this is the special interest group that we have, or working group that is trying to affect compliance, both the understanding of existing compliance requirements as well as being able to influence new protections for data in use. And they have a document that you see linked there for guidance on how to treat the payload that you put into a trusted execution environment. And they're looking for feedback on that. So please bring your expertise over to that document and help them out there. The second link that you see is for the mentorship program. So one of the things that we do to grow the community is to make sure that we're able to bring new talent in. And that involves facilitating internships between new contributors and maintainers of our projects. And so there's new mechanisms for that going in. So you can see PR 223 on the governance repo. We'll probably need a proper agenda item to work through that, but I would like people to be up to speed with that so that we can have that conversation or get it merged in offline. Any questions on the old business from the last session? All right, getting into today's work, I do not see Mike on the line, so I don't think we have any new announcements, but I'll pause for a moment in case somebody wanted to get something in and didn't get it to the mail list.
So, hey, this is me, Fitz. So I'm not sure if that counts as an announcement, but I already see that my name popped up now as a voting. Wait, actually, let me be nice and open my video. Just see I forgot to do that. Hey, hi. That we already showed up as a voting members, but I didn't know this was already there. So yeah, just to say, if there's anything to contact us or to say hi, like, yeah, you see my email there. So I will be the one trying to attend the TAC regularly from now on. And we're still trying in the face of getting everything together to have some more involvement. So I think it takes some time, but we are I think open and trying to come out more. So not sure if that counts as an announcement, but just wanted to say that hi, like an official hi this time.
Thanks, Fritz. And that does count as an announcement. I'm sorry, my eyes glossed over that we actually have the slide updated for you. I was told the official announcement for NVIDIA joining was Friday, so I was going to try to be quiet about that. But
it's
no
already on the
need
website. I also saw that. I didn't know it. Yeah, that's why I also wanted to ask if there's already been something official, because it's on the website, but I also didn't get anything. My name just popped up now.
Okay. Well, thanks for joining. Thanks for being the point person from NVIDIA. And would you like to say a little bit about what you work on with confidential computing?
Yeah, sure. So I don't have anything kind of prepared or anything official yet. I think last time when TikTok joined, you said it's would be nice to have like a company presentation or something like that. I can look into that if we can do that something in the future. I personally am on the networking business unit, so I'm working on the NIC side. So we have network cards and data processing unit cards, like smart NICs and super smart NICs and whatever you can call it. I'm not in the GPU side, but yeah, the GPU side has some combination computing stuff. And yeah, we're also working to make it also cross on networking cards. So that's my area, my personal area. But yeah, I think you can still contact me for everything that sounds sounds related, and then I'm happy to find people internally that might know the answer to everything.
Fantastic. Well, once again, thanks for joining. We also have Eric from Cisco, who tends to join a lot, and he's also got interest in confidential computing with networks. So there might be some good discussions to be had along that subject matter, because I don't think we really get into networks and those sort of newer forms of accelerators very often yet. It seems like a ripe area.
Yeah, looking forward. Sounds good.
Okay. Do we have Pawan on the line? I will turn it over to Mr. Kandavali here to talk about what's happening in outreach.
Thank you. This might not take too long, but do you mind if I just quickly share just for people to follow along?
By all means.
There we go. There we go. Okay, I cannot take away control from you, so that's good. Let me just see. Do you folks see my screen?
Yeah.
Perfect. So let me just. Hello, everyone. I mean, I've introduced myself in the TAC before, but let's just doing it again. Pawan Kandavali, I'm from Microsoft, work in the Azure Confidential Computing team. I've had quite a few years of experience in confidential computing while I was with the Royal Bank of Canada, and then for Tanix, and now Microsoft. The reason I'm here today, I just wanted to give a quick update on some of the thinking on the outreach side in terms of demos. So the outreach team does quite a few number of events. I thought Mike was going to be here to talk about a few today, but there's lots of engagement there in terms of events and speaking slots. And one thing that we felt missing was to have any demos to sort of engage, whether it's customers or even developers who are interested in confidential computing. So the idea is to start sort of curating demos focused on our projects, but it doesn't necessarily just have to be that. It could be expanding to more confidential computing use cases in general, but we do want to sort of promote the projects that CCC supports as well. Sorry, predominantly support them and also expand to other use cases. In terms of formats, like the way I felt video demos work, I usually have a video and then have clear instructions on how to reproduce the demo. So that might be a good format, but again, it's not limited. We can think about other ways to do this. We have a GitHub repo sort of set up to start curating them, although we need to work through the operating model here, and I can definitely use some help there. And basically the ask is, if you have any demos, maybe I see VirTE having a demo today, so maybe that can be part of the repo. But the idea is if you have demos or something to showcase that we could use on events, that would be amazing. So please reach out. Have my email here, or you can even just reach out to the outreach committee email mailing list to send a quick note. There's no planned meetings. I don't think we will need a dedicated meeting for this. We can perhaps do it asynchronously or have specific parts of the outreach meeting just dedicated for this if we need to meet. But I think that's pretty much it. I just wanted to say that, look, we are looking for demos that we can use for community engagement as part of these events. So please reach out if you would like to contribute and work with us on this.
Great. And so I understand this to be separate from the webcasts that we've done in the past.
Yes, so this would be separate. Like this is some of the physical events that we are going and attending to engage them there, or even let's say if we have a booth at RSA or part of a booth, I don't exactly know, but we can even showcase them there, have them running in a loop. So yes, it's different than what we had before.
Great.
Okay. I'll stop sharing and put my email in the chat as well. So please reach out if there's an interest here. Thank you.
Yeah, thanks a lot. And we've got 3 or 4 new projects in the last few months. What we've historically done is when a project joins, they will do a webinar, and that helps introduce the wider world to what they're working on. And it seems like projects should be able to generate content that works both for that webinar and then a subset of that that's a demo that would be repurposable across these events. So really encourage the projects out there to take advantage of that. So I happen to grab the webinars page. So some of these, it's been a while for some of our projects to get going on there. So if you're putting together content, you can probably go in both places and you'll be able to get a lot of return on that.
I do not know about this webinar page, but I'll take a look as well to see if there's things we can repurpose there. Thanks for that, Dan.
Yeah. All right, and now I think we are on to the NARCS review, and I saw Richard in the list, and
Hello.
we also have Gregory. Hey, Richard.
Good morning. Nick Vidal is on the line as well. So if I may be able to share my screen.
Yep, I will stop sharing again.
Let's see. Sorry, it's been a while since I've used Zoom.
For me, it's kind of bottom center of the screen. There's a share button.
Oh, right.
So while Richard's getting warmed up here, for those who haven't seen NARCS, I think it was our first project in the CCC. And it's got a fun mix of ingredients. So if you're into WebAssembly, then this is the project for you.
All right,
You're
I'm
into
gonna have to
TEE.
I'm gonna have to quit Zoom so I can give it permission to share my screen. So thank you, Apple, for that.
Richard, I can share my screen. Let me give it a try.
Oh, okay. Okay, perfect. Cool.
All right. Yeah. So hello, folks. I'm Nick Vidal. I'm the community manager of NARCS, and this is Richard.
Cool. Go to the next slide, I guess.
Richard, if you'd like to introduce yourself as well.
Sure. Richard Zach here. I've been on some of these meetings kind of sporadically, so I guess I could reintroduce myself. I was working on NARCS at Profian for about a year, previously at Booz Allen, back at Booz Allen Hamilton, and trying to work with Bob and Greg to get Booz Allen and clients interested in confidential computing and hopefully NARCS as well.
Wonderful. And I'm Nick. I am the community manager of NARCS. And last year I was serving as the chair of the outreach committee for the CCC as well. So basically this is the agenda for today. And so right now NARCS is under the development stage. And we have, it was supported by Profian, a company that existed before. And now we are kind of in a survival mode, and we'll explain a bit more about this later. So, Richard, would you like to take the goals?
Sure. So yeah, the goals, at least as far as I see them, is an easy deployment of WebAssembly workloads on AMD or Intel trusted execution environments, currently focusing on AMD SEV SNP and Intel SGX2 or the SGX EVMM. And the WebAssembly workloads allow for application privacy as well as data privacy. And we have a nice modular design for the various components so that in the future we could support other technologies. I really would like to get some ARM support in there soon, RISC-V eventually, and whatever else we can get working that also works with WAS and time. So as far as progress, NARCS has been kind of getting back on its feet gradually after Profian had closed. What we have done so far is we have the CI servers, the servers running with SGX and SNP. I have received them. They are up and running at my house so that the code can be tested against real hardware. Steward and Drawbridge were moved from the Profian repository to the NARCS organization, making it essentially part of the Linux Foundation. Steward does the attestation and provides a signed certificate if and only if the attestation passes. Drawbridge holds the WebAssembly workloads and releases those workloads upon receipt of or a connection with a Steward signed certificate. So this way we have workloads that are secured and can only be deployed to only deployed to fully attested TEE environments. Last October, we had put together a slide deck regarding some future plans for NARCS that was presented to the TAC. And we have some of those slides at the end of this slide deck as well. We've updated the SNP patches from version 7 to version 10, thanks to Tom Dorman. Right now, I've been working on updating a lot of the dependencies for Steward, Drawbridge, and the various Rust crates that NARCS owns and ultimately are used by NARCS. Some of these dependencies were have just become out of date, or in some cases abandoned and needed to be replaced. Some of these dependencies also are including CI actions. I'll talk a little bit more about that. As far as community work, I've been working with Jacopo, a PhD student from the Politecnico di Torino, and we provided him with some advice, some code snippets, and hardware access so he could work on his thesis paper, where he discusses confidential computing with NARCS and Steward. And my main thing at the moment is continued working on these updates. Drawbridge here is kind of a bit of a blocker for getting NARCS fully up to date with dependencies due to how NARCS depends on Drawbridge, and there's a lot of crypto libraries that were otherwise clashing with each other, but it's happening. So, sorry, Nick, I think you're speaking and you're muted.
All right. So even though the project is on survival modes, we've been getting some progress and even presenting NARCS at some really interesting events. So last year, I presented NARCS and confidential computing at Rust Lab. This is one of the leading Rust conferences in Europe, and it was very well received. I think we had over 100 Rust developers attending my talk, and I have a report about that. The video recording is not up yet. I'm waiting for that. Also, Richard, maybe you can talk about Europroof nets.
Sure. I was invited to speak at the Europroof Net meeting in Dresden, where I talked about Steward and Drawbridge and using certificate signing requests as a mechanism for remote attestation, and especially about how NARCS does it. The conference was about formal methods for computer security, with a focus on confidential computing. So there were a lot of other people talking about other ways that remote attestation is done, including attested TLS, and met some other interested people, or also interested in confidential computing. So definitely learned a lot.
What's interesting about NARCS is that it's not just about confidential computing, but about WebAssembly as well. And so recently we were invited, Richard and I, to be part of the program committee of WESCOM. This is a Linux Foundation conference. Actually, it's one of the most important conferences around WebAssembly. And it's very likely that Rich will be part of the program committee. They're still selecting that. And this event will be happening in Seattle.
Yeah, and I did submit an abstract, so I might be speaking as well. As far as budget,
so in these conferences, when attestation comes up, do you have the sense that you are introducing a new concept for people, or people already have familiarity and you're more adding depth to what they know?
yeah, option two. At this conference in Dresden, there was a lot of talk about attestation and what goes into it and how it's done. So it was just presenting our approach, but yeah, people had a good understanding.
Great.
As far as operating budget, we don't have any money. It's right now it's just a volunteer operation. I did go to a conference that was already approved by the TAC, so that will be coming. Now going back to the CI actions, I was basing these slides off of a different slide deck that was provided. So the other slide deck was talking about the open security practices for open source projects. This isn't something that I've started on yet. in terms of getting the security, the badge up and running on the website for NARCs and for the various Rust crates, but I will work on that soon. But I have started going down the road of looking at the removing some of the abandoned crates and the abandoned CI actions. I actually do use the Open SSF badge on some other personal projects, so I am familiar, and so I know that one of the things that it does look at is abandoned CI actions and crates. So I figured I would start there.
That's
So
fantastic.
I believe all Linux Foundation projects have to adopt best practices and also do some security scams. So right now we're focusing on keeping anarchs up to date. And as Richard mentioned, we're looking also at those Open SSF best practices as well. So here, Richard and I, last year, we were trying to figure out how to keep anarchs alive, given the restrictions, and we created 10 steps of what needed to be done. And so these 10 steps are listed here, and you can see that we have progressed quite well. We have some check marks of things that have happened, and so we are going to go over each one of those very briefly. So let's start out with the relations of steward drawbridge and benefits. As Richard mentioned, these projects, they were part of Profion, and they were actually on the Profion repo, and we moved that to the anarchs org. They were using AGPL 3.0, and now they have been relicensed to Apache 2.0, thanks to Nathaniel. So he allowed to relicense those projects, right?
Well, we're still working on the benefits. That hasn't been relicensed yet, but that should be simple.
Okay, great. So just a recap: Steward takes care of attestation, right? Drawbridge is a repository service for WebAssembly workloads, and benefits is the try anarchs, a way to display demos. And this is all being donated to the Linux Foundation. Richard, with you.
Sure. So we had these two CI runners that Profion had in their possession, presumably at the office in Raleigh. When Profion closed, these went to Red Hat, and the spring of last year, these things were sent to me. And so it took a little bit of time to kind of get everything configured and running, but they're in my basement. And it did have a little bit of difficulty getting the CI part working properly. I was trying to follow some of Nathaniel's good ideas around Docker and Podman and stuff, but had some issues. So it's working at the moment, but there's still a little bit of improvement to be done there. Sub-steps of this, I would like to run at least start with a public steward. And it would be nice to be able to re-engage with Equinix. I did have some initial talks with them, and they kind of stopped answering me. I don't really want to run a public steward from my home, from my house, but I'm not entirely against it. I can think of some ways so that maybe traffic isn't directly coming to me, but that's things to investigate. So one of the things that we wanted to do at Profion was to have a version of the steward that could use an HSM so that we could have a proper certificate authority. And this way, this would allow people to have some drawbridge or some steward that they could play with, where specifically have this certificate, this root certificate they could play with, but then also experiment with having workloads communicating with each other and using the shared common steward as a way to show that you can trust a remote application. but I need to figure out how to bootstrap the keys from an HSM since I have not used an HSM before. But then also thinking about, this doesn't need to be high availability. This can be kind of a beta thing, just not as a way, at least in the beginning, to be a real CA that people would actually use, but more just as a way to kind of get people familiar with it, to encourage use of NRX. So it would be nice also to have a public drawbridge. What we had in the past was a public drawbridge, which had a bunch of WebAssembly applications that we had created. And this would allow for, well, this would work with Benefice, and Benefice would allow people to see these applications and in a couple of clicks, either deploy something from drawbridge or upload their own WebAssembly application. And just to have, I think it was like 90 seconds or a minute, or sorry, 2 minutes maybe, try to interact with it and to see that it does actually work. They could also communicate with it themselves with their own application to also see that it has a steward signed certificate. We had some interesting things here with the confidential trading and the greenhouse monitor were actually from Microsoft, where it was using C# .NET, all compiled into a WASM binary. And the codecs here, pardon?
Yeah, what's interesting about this is that since we use WebAssembly, this is technology neutral. It doesn't have to use confidential computing. So all these examples that we have here, they could work under other platforms, and they are just WebAssembly applications, right? So we have several examples in 15 different programming languages, and they're all available on GitHub under the NRX org.
Yeah, that's a great thing to mention there, is that one of the things that NRX does for you is that the application isn't aware of confidential computing, and NRX handles the attestation and then uses the steward certificate to wrap the TLS connection for the WebAssembly binary. So all of the connections have in the tested, or essentially a tested communications, because it's using a client certificate from steward, but then also the WebAssembly binary doesn't have to use doesn't have to do crypto. So anyway, it'd be nice to kind of get some of these back.
Yeah, one of the most interesting demos that we had was Try NRX, which allows people to actually experiment and even uploads their own WebAssembly applications, and also use the ones from drawbridge. So it was a very easy way to introduce confidential computing right from the browser. They could try any one of those examples. And here, for example, we have the .NET example that we mentioned using WASI. And so we also had a game based on Wordle, where you have to guess the words in a multiplayer version. And what's interesting about this example here is that there were 3 ways to play, just like Wordle, one which was a multiplayer, and one where we actually gave the keys, the root access to the server, and the players have to guess what were the words in memory, right? If they could break NRX and find those words, they won the game. So that would be like the most challenging world game that there is. So it was pretty neat, and we want to bring back this to allow people to try NRX, to understand a bit more about confidential computing and also about WebAssembly.
Just to adjust the comment that Dan had left in the chat. This is my first time doing a review.
That wasn't a comment for you. That was a comment for the audience, so that we've got new TAC members who haven't been through this. But everything you're covering is great.
Okay, cool. Okay.
Yeah, so our main goal for now is to keep interest from the community, and we have several target audiences. So around confidential computing, around WebAssembly, around Rust, and attending those conferences as possible. Yeah, right. And so I think we are getting some really good feedback from the developers, from hackers, and security folks as well. Maybe Richard, you can also talk about some potential custodians.
So these are not anything official. This is kind of Nick and I brainstorming who we think would be nice to have some kind of a custodian relationship with for NARCs. You know, I'm hoping Booz Allen that I could maybe get Booz Allen interested. You know, that's certainly not guaranteed or anything. But yeah, just a couple of companies that we feel would do a good job of supporting and helping NARCs to grow. But yeah, and then the other thing too was, you know, there's been a couple of talks with some of the people from the Attested TLS group, and they've expressed interest in having NARCs implement Attested TLS. And my response was, you know, I think that would be fantastic. You know, NARCs doesn't have to just use a steward, but you know, if you'd have a WebAssembly, if you'd have a workload that needed to be able to communicate with some other Attested TLS clients or servers, then it definitely makes sense to support additional technologies as well.
I think what's so interesting about NARCs is that the founders of NARCs, so Mike Purcell and Nathaniel, they had a very ambitious vision, and they actually built this on top of two emerging technologies. So WebAssembly and confidential computing. That's the good side. The bad side is that we have to wait for those markets to mature. And so to catch up with the vision that Mike and Nathaniel have, right? And so this is what we're hoping to do, to wait for those markets to mature. Just recently, WASI 0.2 was released. So this was in February. And WASI is so WebAssembly, there's the server side and the front end side. WASI is with regards to the back end, to the server side. And we need WASI to progress, to allow for great applications to run on top of NARCs. We see that this is being led by the Bytecode Alliance, which is a nonprofit. Nathaniel was one of the co-founders, I believe, from Bytecode Alliance. And we're seeing a lot of markets adoption driven by these companies here: VMware, Docker, Fastly, Fermio, and Cosmonic. So I think it's just a matter of time before WebAssembly catches up, and it was a huge topic at KubeCon 2 weeks ago. And so I think NARCs has a potential there as well. And also we have to wait for market demand from confidential computing. The CCC is driving that, is leading that, right? And so market adoption is happening from the hardware companies, cloud companies, and services company. I just named a few companies here and startups, but we feel confident that this will, these two technologies maturing will help NARCs. So what we're trying to say is that NARCs is still very much relevant and very much alive, despite all the challenges, right? Richard and other volunteers are trying their best to keep NARCs alive. And we also appreciate very much the help from the Confidential Computing Consortium with that regard. And we are trying to bring NARCs as an easy way to showcase confidential computing and WebAssembly and showcase that events and other conferences as well. And I think within 1 or 2 years, we're going to reach a tipping point, and perhaps we can revive Anarchs. At least that's our hope, right, Richard? If you have any
Yes.
words.
No, just my main message is, you know, NRX is still here. It's not going anywhere, and we're still keeping the lights on.
That's fantastic. I appreciate the extra effort that's involved. It's tough for projects and the maintainers who are so attached to them when projects go through their ups and down cycles. And all projects inevitably go through both the downs and the ups. In addition to the multi-TE architecture and the use of WebAssembly, one of the other things I like about NARCs is the Rust implementation. So Rust is super popular, especially amongst the security-minded development community out there. I think that's another sort of box in its favor. I'm curious to hear if there's any questions from anyone else in the audience, you know, particularly if you are new to confidential computing, kind of want to understand where this fits into the landscape better. The slide, 1 or 2 slides back, was somewhat incomplete in the number of providers. So in addition to the CPU vendors that you have there, there's also RISC-V coming up. And we have our new friend joining us from NVIDIA, talking about not just GPUs, but DPUs, NPUs. And on the cloud side, Alibaba, IBM Cloud. I would be surprised if you can find a cloud, a top tier cloud that does not have confidential computing at this point.
Yeah,
I don't think
I would definitely love to have NVIDIA confidential GPU support in NARCs. That would be amazing, as well as, you know, and the other technologies mentioned as well for AI and computation.
Yeah. Fritz.
Just to add there, IBM is also a hardware provider. So secure execution for Linux on IBM hardware is also confidential computing enabled for some time now.
Thank you. Go ahead, Fritz.
I want to start by joining Dan there. I also always like Linux for what you guys do. I have like a broad question. Can you maybe say, if you could realistically dream? So I'm prepositioning the dream with like realistically dreaming. What would you wish for? So you already mentioned in the chat that you don't have TDX yet. But for example, is that in your realistic scope of what kind of you might be able to do in the future, or is there just not manpower enough for you guys to do more? Which is, I mean, totally realistic, right? Just trying to figure out what are your current hopes and dreams of where to go next with Enox. I already mentioned GPUs, but like maybe there's more to hear, and maybe there's like some folks in the audience that have ideas of how to do that.
Yeah, I'm very optimistic to see how Anarchs will be 1 or 2 years from now, once those technologies mature. Now, Richard, if you want to be more specific and discuss that.
Yeah, I personally would love to see support for TDX, RISC-V, ARM, CCA, you know, and then, you know, right now we're working with WebAssembly, but, you know, one of the things that I kind of wondered if it would be viable is to have a backend that maybe we could use to maybe support like a Python application as well. You know, because our backend for WebAssembly does the remote attestation and runs WebAssembly, but maybe there's a way to tie in like the Rust Python project so that you could run Python applications or WebAssembly applications. You know, because it's all in a modular fashion. But yeah, supporting...
I'm not familiar with that. You said the Rust Python project?
Yeah, there's a Rust Python project where folks have been rewriting Python in Rust. And it's Apache Tube licensed, and you know that could be an interesting thing, since that was always a pain point at the time when we last looked at it, where folks wanted to run Python applications, but getting Python to work with WebAssembly was a bit of a pain point. Nathaniel, I'd love to hear what you have to say.
Yeah, just two comments. The porting NARCs to TDX shouldn't actually be that big of an effort. It's already running on SEV, and so an x86 backend is there, and it really just needs to handle some of the TDX specific stuff. So an enterprising student who felt that they wanted to do something really interesting, that would absolutely be something that would be achievable. The other issue I was going to mention was I actually just saw some news this week about running Python and WebAssembly on Twitter. So I know people are working on it, and it continues to mature. So just FYI.
Sweet.
Yeah, what's interesting about WebAssembly is that it's not just the technology WebAssembly itself maturing, but support from each language. So Python, Java, C#, all those main languages, each one are going to get, there are different levels of support. Right?
Okay, any questions from maybe any of the Booz Hamilton folks who came along to the meeting? I imagine that you don't get exposed to this quite as often as the rest of us.
No particular comments from me. We've been particularly tracking this through Richard, and I guess my one observation is it's really interesting to see this group come together and not be a collection of separate interests, but I definitely pick up on the vibe of people are well aware of each other's work and see how it supports in each piece supporting each other, and it gives additional confidence in the maturity of this activity.
That's great to hear.
Yeah, and the same for me. It was, I guess, we're trying to gauge the maturity, the market ready, how the market is ready for this. I like the idea of demos that we could show people. I mean, Richard has convinced me personally and my sphere of influence that this is a technology, awaiting important implementation. We just have to figure out how to do it.
Great. Okay, well, thanks for putting together the presentation, Richard and Nick. Always great to see you in our meetings. And
thank you
for all
Thank you.
And for all the TAC members out there, one of the other things that we haven't probably done enough of is maybe just find an hour on your Friday or something and pop over to one of these projects like NARCs, find an issue that's stuck, and maybe you can get a PR in or help get a review in for a PR that's looking for another set of eyes.
Yeah, maybe actually I have a second question. So because Dan was nice enough to link the governance document. The first one immediately said, does the description need change? And so I just checked it out. And hearing of the steward attestation service, it seems like you're branching out a little bit. So do you folks feel like it changed a little bit what you guys are doing? Because I don't, but I mean, it's nice to see a service like Steward and have other services, but just wanted to hear what Richard thinks now that he's here, and I can just ask a stupid question instead of reading through the documents myself.
Sure. I think one of the important things about confidential computing is not just securing your application, but being able to communicate, for your application to be able to communicate that security to other entities. And so we felt that having a service that was separate, that could sign the certificate, and then just knowing that if you have a certificate from this, parent entity, then you can trust that it's secure. So I don't think that we have really branched out directly from what NARCs is doing. But I think we kind of wanted to have a holistic view in terms of, running it and deploying it in kind of an easy manner. In this way, I mean, one of the things that we had worked on too was some kind of integration with like a Docker or like a Kubernetes or an OpenShift, so that you could have some configuration, and then you could just say, hey, NRX, go pull some workload from this drawbridge instance, and then it handles the attestation and everything, just to try to reduce the friction, just to make it easy.
Yeah, makes sense. Just wanted to check what your thoughts are. Thanks.
Yep.
Okay, well, thanks again for the presentation, and we'll go ahead and move along in the agenda. And everybody has the contact information for the presenters there in case they want to ask additional questions. The next thing is the VerTE demo, and I think we have Tyler on for that.
Hello. Is it all right if I share my screen? I have some
Please
slides
do.
and I have a demo. Great.
And just for time budget purposes here, how much time were you looking for this?
Probably about 20 minutes, if that's all right, with a demo. I'll go into it a bit. Yeah. So are you able to see that all right?
Yep.
Okay. So this part of this talk kind of goes in. If you see down in the bottom left there, it's Container Plumbing Days. I'm actually giving this talk in person in about a week and a half in Seattle for Container Plumbing Days. So there's a part of it that goes into the introduction of confidential computing, which I think I can skip over most of here, and we can get it. So I only think it should be about 20 minutes. But to begin, hello everybody. I'm Tyler Finelli. I'm a software engineer at Red Hat, and today I'm talking about confidential containers with the Krun runtime, and it's also broadly of how we kind of extended existing container projects to run virtualization and run confidential computing with them. So to begin for that, I mentioned this Krun runtime, and what is Krun? Krun is basically an extension of the crun container runtime with added virtualization capabilities that we've worked on. And it basically allows containers to run inside micro VMs, which is a machine type optimized for boot time and memory footprint. And because we've optimized this, it has a much smaller memory footprint than standard virtual machines, as they only really provide a thin layer of virtualization and wrap a container's workload with a minimal amount of devices around inside that container. So that was the initial purpose of the Krun runtime, just to offer virtualization isolation capabilities inside of a container. And you may ask, why would you want to do that to begin with? Confidential computing aside. So why you would want to do that to begin with, I give you a scenario. We have 3 containers running on a host system. They share the resources. They're completely unaware of each other. They're typical workloads, nothing out of the ordinary going on, when all of a sudden one of them is acting maliciously. It escapes its container and can escalate the privileges, and then allows for spying, tampering with those host OS privileges. There's a number of container tools in place to try to prevent this, offered in Linux and just in user space in general, to mitigate this, but still a possibility. There are still attacks that are being created and found today. So this is a legitimate concern if you would like some isolation in your system. So the question is, how can we further isolate containers from each other, even the host itself, so that they can't do that? And I give you the previous scenario with VM isolation. In that previous scenario, if you have a malicious actor that tries to get out of the container, try to escalate privileges, something like that, they can escape. They can still probably escape with privileges, but they're still locked into that virtual machine environment. So a lot of the exploits that are built around containers are much harder to do in practice now when you have a virtual machine layer around that, and it doesn't affect the other containers on the system as much because they're still sandboxed in that virtual machine. VM escape is possible, but it's much more difficult in practice to do. And because we can isolate these applications that are potentially malicious, we could greatly increase the security of the host system as well as other containers running on it. And so just an overview of why we originally thought of VM isolation of containers is that it provides that extra layer of security for running containers that are potentially buggy, malicious, etc. And some of the common attacks for containers can be mitigated completely with an extra layer of isolation. And I will note that with KVM acceleration, there's a near zero performance degradation in using VMs, because essentially you're running the workloads on the hardware just as you were if you were running the container natively. So that's our initial goal with isolating containers inside virtualization. So the question is, how can we, there's many good container projects out there that do the job well. So instead of reinventing the wheel, we thought of how can we leverage the existing container projects to build VM isolated containers. So we'll go through a number of components that we've kind of used as our base and then extended to bring VM isolated containers. So the first component is CRUN. CRUN's basically a fast, low memory footprint OCI runtime. It's your standard OCI runtime, and one important note that you'll see in a moment why it's important is that it's written in C. But that's basically our base of the krun runtime is CRUN. The next component is libkrun, and why I mentioned that CRUN, why it was important that it was written in C, is because libkrun offers a C API to run processes in a KVM virtual machine. So basically, it integrates a hypervisor solely for the code you're going to run virtualized, and that is the hypervisor only manages the libkrun VM you create when you create a VM through libkrun. And basically, the VMs that you're going to create with libkrun are micro VMs. They run processes virtualized with the minimal amount of emulated devices. So they have a much lower memory footprint than standard virtual machines. It's basically just, like I said, that thin layer of virtualization on top of the workload or the processes that you're looking to run in a container. So that was the idea, that we wanted to keep it low memory footprint as possible, rather than a standard VM, which could have multiple devices and lots of memory allocated to it, etc. And with this library, we've been able to abstract most of the complexity that comes from VM management. And if you see on the right here, we have the libkrun header file, how we present the C API, and just a number of the APIs that you're able to do. There's much more that I couldn't fit on the page, but with setting a VM configuration, such as the number of vCPUs you want to run with it, the amount of RAM, you can set a root disk for storage. You can add VirtIOFS devices, and you can set where you're going to execute when that VM begins running. And then the krun start enter is actually to begin running that VM. So essentially, libkrun is a C API for providing virtualization capabilities to your processes. I should also note that although it's a C API, libkrun itself is written in Rust. As I know a few people here are fans of Rust, so I should probably note that. So that's what is the krun runtime. It's basically the CRUN runtime, and it's extended to use the libkrun API to virtualize the container's contents. In essence, you can think of it as a virtual machine, a micro VM inside of a container. And kind of how the communication works with orchestration software is that the container orchestration software communicates with CRUN, and then CRUN uses the libkrun API to manage the virtual machine. So that's sort of how they're able to talk to each other, and you're able to orchestrate your containers, even though they're running virtualized and separate from the host. Is there any questions so far on either? Where I see Nicholas has a hand up.
Yeah, I was just curious. I'm familiar with the Kata containers project, which is the basis for confidential containers, as well as knowing that Kata is very active. So I was just curious, there was no reference on Kata, or is it just the K of Kata, which is your krun?
So Kata and krun are not the same thing, if that's what you're asking. Kata has a bit of a different model. It does use virtualization as well with the containers. The important note that I'll mention is that Kata usually what you have with Kata is a virtual machine running many containers. With libkrun, it's a one-to-one mapping of one container runs one micro VM, and that the virtual machine manager that libkrun uses, it only manages the VM that you created. So it's a bit more lightweight than Kata. But when you're managing a fleet, such as on a cloud, a fleet of a number of containers, and you want to have them all running confidentially, that's where Kata, if I understand correctly still, where Kata is built for. As in, you can manage with Kata, you can manage a fleet of containers inside of a virtual machine. When with krun runtime, you're running a container with a virtual machine inside of it. Have I explained that a bit more? Or do you understand what I'm getting at?
Yeah, I think so. It's just for awareness. There's also that, and that's a Z-specific thing. There's that RunQ project, which I think does something similar, which is a Docker runtime within a KVM, just as awareness. And yeah, we are working closely with the Kata project as part of the confidential containers, and that's why I want to understand that more. Thank you.
No problem.
I have just a question regarding that as well. I did not understand that confidential containers use Kata containers for running multiple containers within one VM. On the contrary, I think it's used exactly in the same context here, but they are just using Kata containers because they are VM based, so they can actually instantiate the enclaves using the VM technology like with AMD SCV or TDX.
I'm sorry, go ahead.
I was just going to say, I think the important difference is that the Cocoa project has an entire pod as its deployment artifact, where krun has a single container instance as its deployment artifact.
That's right. Okay, so any more questions?
I think maybe I lost the beginning part of this slide after that conversation. So virtual machine inside of a container on your second bullet?
Yes, I'll actually, that you could take me to the next slide, where on the left here we have a traditional crun container. It's just the container context running on top of the runtime with your workload running inside. And on the right here, you have a krun container with you have your container context, and then inside of that is where you manage your virtual machine. That's a way you can kind of picture the difference between the two and what's changed with krun. Does that answer your question, Dave?
Maybe. So you mean it's namespaced, or what is the container construct?
So as far as on the host, it does have a separate namespace, but inside that, the virtual machine layer is really just is only talked to through crun. So it's still encapsulated in crun's name, in the namespace you run that container with.
Okay.
So we'll look at a bit of trade-offs here. With, as I mentioned before, with the VM isolation, you have for potentially your malicious, buggy workloads that can affect other containers on a system. You can mitigate that with a near zero performance decrease. One drawback I will say is that sharing resources with processes and other containers outside of the krun VM is more difficult due to it being virtualized. There's ways to mitigate that, but it is a bit more difficult than if you were just running them as regular containers on the system. And of course, one thing we can take advantage of now is the ability to take advantage of trusted execution environments for confidential computing. One thing I'll note before I get into confidential computing, so I do come as a member of the Verdi project. Everything that we've done to enable confidential computing in the krun runtime is built out of Verdi components, which is why I thought it'd be fitting to bring this to the consortium, because everything that's enabled confidential computing here and has been done on the guest side to facilitate attestation, as well as an attestation server that I'll be showing, They're all built from Verde, and they're all available from Verde, or at least will be at some point. We're still working on releases. So we have, I think I can, kind of skip over this slide a bit, but we have host OS resources. Of course, we're not fully protected because if there's a malicious system administrator or rogue actor somewhat, they can still peer in if they already have host OS resources, even though the containers themselves are protected from each other. Something with sensitive information, bank medical records, trade secrets, sophisticated attacks can gain access to the information. And this is really the motivation behind confidential computing, at least part of it. So we'll talk about how we do confidential computing with KRun. We all know that we all know that confidential computing uses trusted execution environments and it focuses on data in use, the RAM, CPU registers, and it gives the ability to run their applications in untrustworthy environments. So how we do KRun confidential computing is that the libkrun virtual machine monitor that I mentioned before packages the kernel, the firmware, and the init RD needed to run the confidential workloads. So you really specify the container that you want to run, and libkrun already has a kernel stashed away, kernel, firmware, and init RD that it's going to use to both bring up the confidential guest and attest it. And each VM region of this is measured and encrypted to ensure that all the parts of it are running confidentially. And at that point, one thing I'll note, and we'll get into attestation now, is that we actually bake attestation into the VM image, into the container image, and I'll show you what I mean in a moment. But when you first begin running a KRun confidential container, you're not able to run the application immediately. What we do is when building the container image, we encrypt the root disk, which actually contains the application. And then the VM must attest itself in order to unlock that root disk and begin running the application. So using another component from containers, we can ask the question, we don't want to run the application if we're not running confidential. How can we prove that we're running confidentially? The answer is that we have to attest. And I go into a bit more about what attestation is. The two main components that we want to verify our hardware, that meaning that we want to verify that we're running on authentic, trusted hardware from the chip supplier, which can prevent the host from lying about our application running confidentially. And our software, that we want to verify that our application and only our application is included in the secure enclave. What this prevents is the host from potentially mapping some extra unencrypted pages in the enclave to snoop on its activity, such, it's not out of the scope of a malicious hypervisor to map some extra pages in for something like a GDB server to spy on the guest. Or another attack vector could be just not mapping all of the pages confidentially so they can spy on some parts of the memory. So we want to verify that we're actually running on TE hardware and that our entire application is measured and encrypted in that VM's RAM. With that, may I ask, how does KRun attest its VMs? So we actually bake attestation into how we build the container images. Some may recall Builda. Build is a tool to build OCI container images. And one of its main subcomponents is Builda build. It's a subcommand. It's the main command used to build OCI images from an application. Recently, Builda introduced the CW, which stands for Confidential Workload Flag, to build OCI images with KRun VM attestation in mind. Basically, what CW does is it registers build measurements with an attestation server for eventual attestation from the KRun VM guest itself. And I'll go into a bit, I'll show a demo of it doing just that. And I'll go into a bit how confidential workload OCI images are much different than standard OCI images. What I mean by that is that we have confidential workload images, and they contain two main disks expected by the VM. As I mentioned before, we have the root disk, which contains the application code and all the data for that application. And that root disk is LUKS encrypted with a key stored in an attestation server. And then we have a data disk, which is unencrypted, and it contains all of the data needed for attestation, such as the URL of the remote attestation server needing to communicate with. So the basic idea is when you drop into a Krun container on the runtime, it knows to read the data disk and immediately do an attestation, because it can't unlock its root disk and begin running its application until it attests itself. So in that way, we force attestation. And since that root disk can't be ran until it's unlocked, it requires attestation for running. Is there any questions on how we format the container images? And what we're trying to do here, as in force attestation and kind of bake attestation into the image itself?
I think you made it pretty clear.
Great. Okay then. And how we, at this build time, how do we register with that attestation server? Like I said before, we need to verify our software. And how we do that is we measure each portion of the software and compute an expected SHA-512 measurement. The idea is that this is the expected measurement. So we measure each of the components ourselves and register it with the attestation server. When we go to attest, the attestation report or evidence that you give over from the Krun runtime, from the VM guest itself, from the secure processor, would also have a actual launch measurement from the evidence, and then you would compare the two. And at that point, also, we put the URL of the attestation server into the data disk, so when you're inside of a Krun VM, it knows where to reach out to. So basically, an overview of how Krun attestation works. I don't really go into attestation in this talk. At some point, I would like to talk to the attestation SIG a bit more about how exactly we do it, because there's a lot of moving parts there. But essentially, we hand over some attestation evidence. The server does some magic to attest the workload, and if it's successful, it'll get back with your LUKS passphrase to unlock your root disk and begin running. So we kind of bake that LUKS passphrase into the attestation, so on a successful attestation, you can get it sent back to you. And that's how you're able to run your application. A bit more here of how attestation works. We do a hardware validation. I use the AMD 7SMP as an example of how you kind of trace that root of trust from the certificates back up to the AMD's root of trust. So that's how you basically would do hardware validation to understand that you are running on trusted hardware and that you can trust this attestation report and that it's legitimate. And in effect, this means that the host can't lie about running confidentially when you can trace this root of trust back. And the software validation, as I've said before, if you recall that build previously registered an expected launch measurement with the attestation server. And now that it's authenticated the attestation report, we can check the contents of it. We can pull the launch measurement that actually came from it. And then we can compare it with the expected launch measurement that we previously built from Builda. If those two are not equal, there's one of two possibilities. That is that not all of the VM pages were encrypted by the secure processor of, not all the components of our software that were initially running were encrypted by the secure processor, or that extra pages were mapped into VM guest memory. Both of these are not good. They could be potentially someone acting maliciously or something going wrong, but you're not running confidentially. Either one of those scenarios would change the launch measurement, and that's why you want to compare the two to make sure that they're equal. Because either of them being different may jeopardize confidentiality. As I said before, on a successful attestation, the attestation server returns the LUKS passphrase to the VM's root disk, and the VM uses the passphrase to unlock it and begin running the application. So at that point, we've proven that our workload is running confidentially on the host system. So that's the idea with Krun attestation. Is there any questions on on how we attest and what the purpose is of the image.
All good here. Just as a
Okay.
time check, we're around 20-ish minutes.
Okay, thanks. So I'll just do a quick demo and then I will be getting on. So is everybody able to see the terminal?
Yes.
Okay, great. So on the right here, we have an attestation server that we've worked on. It's going to be a Verdi project. I would like to discuss it with attestation SIG, but I don't have the time today. But this is an attestation server that we developed for this. It's known as Keybroker. So we'll run that. And the first thing we'll do here is we'll view a program that we're going to run. So this is basically just a simple web server and has a passphrase stored in plain text memory, static memory. The passphrase is Open Sesame. And the thing we're going to make sure is that we can't read that from the host when we're running confidentially. But the important portion here is that we have the passphrase that should be kept confidentially when we run encrypted. So one thing that we also can do is give over OPA queries. And so one thing, what this basically checks right here is when I said that expected launch measurement calculation should match the actual one from the evidence. That's what I specify here in some OPA queries. And what I'll then do is build the image with Builda with the CW flag. And if you see on the right here that registered on the, I print some information out on this attestation server, and it kind of can tie all of these queries, the reference values. You can see the expected launch measurement there in the measurement of the reference values. That's the expected launch measurement that we're going to compare with the evidence. And there's one retrievable resource. The passphrase is the Lux encrypted passphrase that we registered with the attestation server. So that's the passphrase that the workload needs to get to unlock its root disk. So at that point, down here, there is some identifier information. So we can tie these, all of these reference values, tie this whole registration to a specific guest. And basically, we return a 32-bit host data. What we do is we send that back to Builda. Builda puts it in the data disk, and then we should put it in the attestation report. So when we get an attestation report over, we can identify it. Again, so at that point, we have our container image here. So let's run it. We'll name it server C. Again, it's just a simple web server, so we'll name it server CW. And we'll run it on port 8080, and we'll want to make sure that we're running it confidentially. So we'll use that container image. So what krun then does is it injects and measures each memory region that's part of that container image, which may take a moment. And then you'll see a bunch of stuff go by on the right here, and that's printing. It's basically doing its attestation right from Podman when we run the krun runtime. So if you see on the right here, we've just successfully attested. It eventually presented its attestation report, which was detected to be SEB-SMP. It goes through and validates the hardware, checking through AMD's root of trust. Does something we call a freshness hash. That's just validating that the attestation report is fresh and not doctored in any way. And then we go through and we check the input. The expected and the evidence measurements. And at that point, since we've validated that those two are equal, we've have a successful attestation. At that point, we go to fetch the resource, which is the Lux passphrase, and we have unlocked the. If you see on the left here, we've unlocked the root disk, and then we've mounted it. So we now have a server running. If you noticed before, I called that Podman container server to CW. So we'll see what port that's running on, and we see that it's running on 3889. So we'll curl. So we see that we got the passphrase Open Sesame, and that's stored in plain memory. Plain text. So the confidential VM itself is able to run its is able to read its own memory unencrypted. So if we then try to dump the memory contents of that process However, this is the process running the krun VM. So we use GDB and we'll dump the memory contents. And we have a core, so we can grep for the secret. And we can't find it because it's encrypted. You can take my word that if it wasn't encrypted, we would be able to read that. But in the sake of time, we grep over it, we can't find it. That's because the memory is encrypted, and the memory that was dumped to that file is basically gibberish at that point. So sorry, I had to move a bit quick. I apologize for that for the sake of time, but that's how we're able to do attested containers, confidential containers with the crun, krun runtime. So just a quick status as of this talk. We fully support AMD SetSMP as I've just shown. We're focusing on ARM-CCA, and then we have development underway for Intel TDX. And right now we're preparing an initial release for Keybroker, which is the remote attestation server I've just shown you on the right there in that demo. That I'd also like to talk to the attestation SIG about and how we do attestation. So I just made a note of that. Is there any questions?
I have one. So the other similarities with the Cocoa project aside, there's also a key broker over there and an attestation server.
So that's Keybroker takes its name from the Keybroker service. What you're referring to is now called Trusty with the Confidential Containers project, and that's because the Keybroker service is a way to do attestation. Maybe I should, before I have the initial release of Keybroker, maybe I should release it under a different name because they both of those servers use the same underlying protocol to attest. That's the Keybroker service protocol. However, how they manage reference values and how they attest with rats changes pretty radically right now. It is a pretty radical change right now. So it's not, although they both use the underlying Keybroker service protocol to attest, they're different in just about every other aspect right now. But yeah, you are referring to the KBS protocol, and that the name of their server, which is now called Trusty, was once called KBS. But they are different, but they do use the underlying same protocol to attest from between client and server.
Okay. Can you think of what one of those differences might be, just as one example?
Mainly how they handle. So one thing is that when you register expected launch measurements and things like that, the Trusty server provides something known as the RVPS, which is the Reference Value Provider Service, where you can specify everything at build time of that. You can specify the policy that you're going to have with those reference values at build time, and it's everything that comes to a test. The reference values are pulled from that one file. With Keybroker, you can register. You can have multiple clients register at build. So how we have with, if you notice when we built that container image with Builda, we registered at runtime. The server was running and it had something come along saying, hey, I'm going to attest. Here's my reference values, save them somewhere. And when I come to, when I present an attestation report with the identifier that you associated with it, use my reference values. So you're able to register many different combinations of reference values at runtime, which is important for running lightweight containers with Podman that, they don't last forever. Usually it's a short-lived process usually that you can run confidentially, but you can spin many of them up and they can all register their reference values to be able to attest. At some point, I'd like to go into the details of what I mean. I'm not rushing a bit, but kind of giving summary of how Keybroker differs. But that's a major difference, is that you can specify reference reference values when you register at runtime rather than build time.
Yeah, that's a good example. Thanks. Any other questions for Tyler?
Just to clarify, Tyler, when you say it will be released where actually?
The Verdi project, and so our the protocol we'll follow is we'll release it through the Verdi project with just a GitHub tarball. We'll probably take that and release it for Fedora. At that point, create a Fedora package for it. I don't think it's a binary, which usually doesn't get posted to crates.io, even though Keybroker is written in Rust. But yeah, we'll probably go from a simple GitHub tarball release to Fedora. And we do have some, sorry, one more note. We do have some people in the Verdi project that release for OpenSUSE, I believe. So there will probably be a release for that as well.
Cool.
So just to understand, under under Verti project, there will be a dedicated repo for container-based.
I'm sorry, that I was speaking about the attestation server. The everything that else is here, all the components that I've mentioned before, they're all contained within the containers GitHub organization, which is the same one with Podman, etc. There is the libkrun, crun, everything like that. That's all contained within the containers repository. I was speaking about the Keybroker attestation server. But everything else used to run these is in the containers organization.
Okay, thanks a lot.
No problem.
Hank?
Yeah, hi, this is Hank. Sorry for my shutdown camera. You just released a Red Hat blog post about this. I put the link into the chat. And the IETF REDS model points to an internet draft. You can safely refer to RFC 9334 now. So the link in the blog.
Okay, thank you.
Yeah, so I think this is an easy fix, but otherwise, yeah, also for everybody, there's a reflection of what we just heard on the blog post. All right, Red Hat.
I would say that is also geared towards the confidential Kata containers, but it still has the underlying aspects of attestation. So that's that blog post you mentioned. Although it goes into Keybroker service, I understand it can be a bit confusing right now. That it goes into Keybroker service attestation, but it's really more geared towards the confidential containers rather than running with Podman and the Krun runtime.
Got it. Thanks.
Sure.
And Hank, what was the RFC that you were making reference to?
9334 is the IETF REDS architecture.
Okay.
Thank you.
The thing that we reference constantly.
Basically, yes. So but it's, of course, data tracker is confusing. And yeah, it's basically if you compile the links and never change your BibTeX, then you end up with a referencing draft. That's not a rare thing.
Okay. Well, if you want to drop the best link for the RFC, that'd be great into chat.
Yeah, I can do that. Shit. Okay. Yeah.
Okay. And Bokduk is asking in chat, does a Krun VM run its own OS? And if so, what's the difference between running a confidential VM directly from the host and running a Krun VM in a container?
The first question, does it run its own OS? Yes, we provide we kind of have a Linux kernel that when you run a Krun VM, it's a specific kernel that we've picked because we want there's a few changes we made regarding something known as the transparent sockets layer for networking that helps with communicating with sockets out, doing networking inside this virtual machine. And it's also that we include all the modifications needed for running a confidential guest. So, you need some kernel modules for a guest to fetch something like an attestation report. When we just, with that right now being under development within Linux, we just know we have something that's stable and works for us right now. And we update it when new patches related to guests are merged. So especially for confidential computing at the moment, it's important that we manage our own kernel because we can kind of understand that it works correctly. If we would let users give just this may change when a lot of the confidential computing changes are upstreamed and stable. But for right now, we do have a kernel that you run under. Do you mind? What was the second question?
The second part is what's the difference between running it directly from the host, so running that kind of operating system in a VM from the host perspective versus running a Krun VM in a container?
So the important part is that as I mentioned, the Krun VM is a micro VM. It's much smaller than a standard virtual machine. The other part is that we set it up to automatically, because we've picked the init RD, that's how we're able to force attestation. So when you enter in that VM guest, there's an init binary that's basically run that does your attestation for you. Because we're able to kind of place that into memory, we're able to force attestation. So it goes into more about how we can control the environment to exec into that into your application, but first a test and then exec into your application. And then when your application finishes, the kernel tears itself down, and then the process ends. And that's the whole thing we can do. We can have more control over what runs over on the system, and then we can also have build it for a micro VM purpose. So there's much less resources being put into that VM than a standard one that you would be running.
Okay, well, I hope that answers your question, BuckDuck, and thanks for joining again so late at night. I guess it's coming up at 1 a.m. your time.
Yeah, but I still have questions. I still have more questions. So let's say we are still using the Krun VM, which is a very micro VM. And why don't you just run it directly from the host rather than running inside the container?
So this is mostly built around container images that you can run libkrun actually from a you can use the libkrun. You are able to do that with libkrun. So libkrun provides that C API, so you could run a process within the just a standard process inside the with that confidentially in that. We just extended that for now you have a Krun runtime. If you want to do that with containers you've already built and using the container infrastructure, you can. But using libkrun alone, you could just run it on the host without a container. There's nothing stopping you from doing that.
I see.
The original, if I just a bit of a tidbit, the original name for libkrun was libkip and KIP, and that stands for so KIP is KVM isolated processes. The original purpose of it was for just processes alone. When it was started to think about container runtimes, when the name changed to Krun, but the original name did have regular processes in mind for running in virtualization with virtualization.
Cool. I didn't know that little piece of trivia.
Yep.
I think we have time for one more question. Dresko?
Yeah, just related to the previous question, I think the question was why, and I think the benefit is exactly to run containers and Kubernetes and all the stuff. So for the orchestration purposes, right, to move around and so on.
That's right. Yeah, you get that with containers. You get all that with it. So.
Exactly. Yeah. So just I noted one thing. You said the kernel is teared down when the application is finished. So would it make sense to look at the unikernel, build process then rather than build? I don't know how you build. I mean, from Ultraviolet, we've been engaged in a project we've been building with Buildroot, the kernel. We also had to separate the rootfs and init stuff and attest and encrypt differently in order to get the secure boot and attestation. So it would be good to understand how the kernel is built and how we can control this build, and also would the unikernel approach be beneficial here?
So we're currently exploring a unikernel approach. We haven't implemented it, but it is something that we're interested in for the exact purpose that you just mentioned. So it is something we have in mind. How the initial thing of how we're able to control what runs is basically through the initial RAM disk, the init.rd. And because we're able to kind of bury the attestation code within that, we can kind of set that that's the first thing that's going to run. Just keep note that the Linux that we're using has been, it has some changes to it. It also helps with that process. I don't have the specific details on that, but because we're able to bury the attestation code and control what we exec into after we've attested, that's how we've been able to, and when that process ends, have the kernel basically exit out itself, and the process end its the VM. So when the VM process wants to leave, it can kind of tear down that kernel. As far as unikernel goes, we are currently exploring. I don't have any news yet. It's right now we're kind of just seeing how we could implement it, but it is something we're thinking about.
So for those that don't work with unikernels, does one of you want to give a synopsis there of what that brings?
I don't think I'd be the best person to give it right now. As I said, I've just started exploring it. If somebody else wants to.
So is the idea that at least one aspect of the idea is that the application that you want to deploy, you're just packaging that up into the initial RAM disk, and so then that's built in with this unikernel image, and then it's launching essentially an application directly?
As I understand it, that is very similar. That, as I understand it, that is the basics. One problem that we have with that right now is that when you think about building the container image, we need an outside source to measure the OVMF, the init.rd, and the kernel that we're going to be running all separately in the same to calculate that expected measurement, which we don't know if we can do with just a simple UKI image at the moment. But it's something we're looking at.
Okay, cool. I think I saw some patches go into System D recently to support UKI for adding measurements.
I believe so, yeah.
Yeah. So some interesting space there. All right, well, thanks for the demo. And I think you probably heard at the outset, Tyler, with Powen looking for material just like this and providing a way to help amplify that for you.
Yeah, if just a note on that, I know I've seen on the top left here that this was recorded. If you would like to use this for that repository, you feel free to. Please do.
Yeah, so I'll leave it to you and Powen to connect directly on that. Probably the cheapest and dirtiest way to do that is just to snip this video out of the recording of the TAC, but there's probably a little better way to do that.
Yeah. Well, thank you anyway. Thank you for letting me present. I know it's been about a year since since Ferdy has joined, but I wanted to give an update on what we're on some of the projects. Like I said, all of what I just discussed was mainly Verdi projects that we worked on. So, but thank you for letting me present.
Yeah, by all means. I'm glad to have you guys properly aboard now as a project. All right, so we're down to the last few minutes here, and I think we only need a few minutes to get through the last items. Ben, do you want to take us home through the project pipeline and the budget update?
Yeah, happy to do that. I know there's some new folks here today, so just briefly, my name is Ben. I'm a program director here at LF. One of the projects I help work on or help with is CCC. So just really briefly, project pipeline. The only one we have in progress is Coconut SVSM. And we have documents that are out for signature, which is very exciting, which means we'll be proceeding with a vote in the not too distant future. So that's really good. If anyone has any questions about projects in flight or projects coming into the CCC, feel free to reach out to me. Happy to answer questions. And then on to the last slide I think we'll be talking about today, which is the discretionary budget update. So not a huge update here in terms of where the tax spend is, but I did want to mention this new item that we're going to be reporting on that we haven't been reporting on in previous meetings, which is the Technical Community Architect Travel Budget, essentially SAL's budget. So we didn't have this broken out previously, but we're doing a lot of events this year, and we need to be tracking spend pretty carefully so that we don't run out of travel budget for them. So I'll be breaking that out and tracking that here and reporting on that for everyone. Outside of that, travel budget for projects is still looking good. Test infrastructure is still looking good. And we have some money left over for IT services and collab tools that we haven't spent any money on. Again, if anyone has any questions about the budget or wants more specific information, I'm always happy to meet with you one-on-one to discuss.
Okay, so this is a sort of a minor change from what we've had before. And thanks to Ben for making sure that we surface it so that if any of the other TAC members have an issue with this, you're free to bring it up. But basically, we just want to use the existing budget and reapportion it so that we can do with Sal's rule exactly what we wanted and get them present at the places that we want confidential computing to be highlighted. Okay, that's pretty much it for today, with the exception that we'd like to take just a minute to think about what we're going to talk about next time. And so we have our regular cadence of project updates, having just heard from NARCS today. Looks like OE SDK is on the docket next. All right, so we'll look forward to that for next meeting. And then we have this proactive schedule that we're working on so that we don't need to, on a bi-weekly basis, figure out what it is that we're going to go through. Part of that is the projects, but we're sort of organized around 3 objective areas right now. The projects, the ecosystem, and then the community. And each of us who is a voting member on the TAC and others who have volunteered from the wider community to participate, we've all signed up to deliver across each one of those areas. And I want to sort of build out this pipeline more so that we're in a proactive stance instead of a reactive stance. Each of you, with the exception of maybe the newer members of the TAC, should have an email in your inbox asking you to get on the calendar. So I'll appreciate if you can get that scheduled with us. Related to that is the series of tech talks. So I think we all found this VRTE discussion really informative today. There's a lot of good questions, a lot of good back and forth. And we like to have technical content in these meetings since we are a technical advisory council. We've sourced these in the past through a variety of places: academic contacts, research within our own companies, active open source projects. So that's another area where we need your constant help to make sure that we've got the most interesting new topics coming in. And that should bring us to a close for today. Any last words from anyone? All right, well, with that, thanks again for your time, and look forward to talking to you again in 2 weeks, and recognizing that everybody's doing some important stuff in between now and the next time we talk.
Thanks, everyone. Thanks, Dan.
Thanks, Dan.
Thanks.